ground fault occurs when an electrical current flows from a live conductor to ground through an unintended path. This is typically caused by insulation failure or contact with a grounded surface. The current flow creates an imbalance in the electrical system, potentially leading to tripping of circuit breakers or fuses, equipment damage, and fire hazards. A short circuit occurs when an electrical current flows between two live conductors or terminals, bypassing the intended load. This creates a very low resistance path, allowing a high current to flow, typically caused by damaged insulation, metal shavings, bridging contacts, and faulty wiring. The key differences between ground faults and short circuits can be summarized as follows. Firstly, considering current flow, a ground fault involves current flowing from a live conductor to ground. A short circuit involves current flowing between live conductors. Secondly, resistance differs significantly. A ground fault typically involves a high resistance path, while a short circuit involves a very low resistance path. Thirdly, effects also vary. A ground fault can lead to the tripping of protective devices and equipment damage. A short circuit results in high current flow and the potential for fire and equipment damage. Confusion often arises because both ground faults and short circuits can result in tripped circuit breakers or fuses. However, the underlying causes and consequences are different. Ground fault circuit interrupters or GFCIs protect against ground faults by sensing an imbalance in current flow. Circuit breakers and fuses protect against both ground faults and short circuits by interrupting the current flow when it exceeds a safe level. Remember that a ground fault typically involves a high resistance path and current flow to ground, while a short circuit involves a very low resistance path and current flow between live conductors. Understanding the difference between a ground fault and a short circuit is essential for any electrical apprentice and for ensuring electrical safety. Knowing the causes, effects, and protective measures associated with each type of fault helps in troubleshooting and preventing electrical hazards. In a ground fault, the current seeks an unintended path to ground. This path often has higher resistance compared to the normal circuit, but it's enough to create a dangerous situation. For example, if a live wire inside an appliance comes into contact with the metal casing, the casing becomes energized. If a person then touches the appliance, they could become part of the ground fault path, leading to electric shock. The ground fault current may or may not be high enough to immediately trip a standard circuit breaker. This is where ground fault circuit interrupters or GFCIs become crucial. GFCIs are designed to detect even small imbalances in current, typically as low as 5 milliamps. When an imbalance is detected, the GFCI trips the circuit very quickly, interrupting the current flow and preventing electric shock. In contrast, a short circuit is a direct, low-resistance connection between two live conductors. This bypasses the intended load and allows a very high current to flow. The high current can quickly overheat wires, melt insulation, and cause a fire. Because of the extremely high current, short circuits usually trip circuit breakers or blow fuses very quickly. Circuit breakers and fuses are designed to protect against overcurrent conditions, including short circuits. They work by interrupting the flow of current when it exceeds a certain threshold. A circuit breaker can be reset after it trips, while a fuse must be replaced. When troubleshooting electrical problems, it's important to distinguish between a ground fault and a short circuit. If a circuit breaker trips repeatedly, it could be due to either type of fault. To diagnose the problem, you can use a multimeter to check for continuity between the live wires and ground. If there is continuity, it indicates a ground fault. You can also check for continuity between the live wires themselves. If there is continuity, it indicates a short circuit. Another way to identify ground fault is to use a ground fault locator. This device sends a signal through the circuit and can pinpoint the location of the fault. When working with electrical systems, always follow safe work practices. Energize the circuit before working on it, and use appropriate personal protective equipment such as insulated gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. In summary, a ground fault is an unintended current path to ground, often through a high resistance, while a short circuit is a direct low resistance connection between live conductors. GFCIs protect against ground faults, while circuit breakers and fuses protect against both ground faults and short circuits. Understanding these differences is crucial for electrical safety and troubleshooting. The National Electrical Code or NEC provides detailed requirements for electrical installations, including the use of GFCIs and circuit breakers. It's important to be familiar with the NEC requirements to ensure that electrical systems are installed and maintained safely. For example, the NEC requires GFCIs in bathrooms, kitchens, and other wet locations. It also specifies the ampacity of conductors and the size of circuit breakers. Ampacity refers to the current carrying capacity of a conductor. It's important to choose the correct size conductor for the load to prevent overheating and fire hazards. Circuit breakers should be sized to protect the conductors from overcurrent. The NEC also provides guidelines for grounding and bonding electrical systems. Grounding provides a low impedance path for fault current to return to the source, helping to trip circuit breakers and prevent electric shock. Bonding connects all metal parts of the electrical system together to create an equipotential plane, reducing the risk of electric shock. When working with electrical systems, it's important to use the right tools. These include a multimeter, wire strippers, pliers, and screwdrivers. A multimeter is used to measure voltage, current, and resistance. Wire strippers are used to remove insulation from wires without damaging the conductors. Pliers are used to grip and manipulate wires. Screwdrivers are used to tighten and loosen screws. In addition to understanding the difference between ground faults and short circuits, it's also important to be aware of other types of electrical faults, such as open circuits and arc faults. An open circuit occurs when there is a break in the circuit, preventing current from flowing. An arc fault is a dangerous condition that can occur when there is a loose connection or damaged insulation. Arc faults can generate high heat and cause fires. Arc fault circuit interrupters or SIs are designed to protect against arc faults. They work by detecting the unique characteristics of arc faults and tripping the circuit. The NEC requires SIs in bedrooms and other areas where arc faults are more likely to occur. When inspecting electrical systems, look for signs of damage such as cracked insulation, loose connections, and corrosion. These conditions can lead to electrical faults. It's also important to check for overloaded circuits. Overloaded circuits can cause wires to overheat and potentially start a fire. To prevent overloaded circuits, make sure that the total load on a circuit does not exceed the ampacity of the conductors and the rating of the circuit breaker. If you are not comfortable working with electrical systems, it's best to hire a qualified electrician. Electricians have the training and experience to safely install, repair, and maintain electrical systems. They can also help you identify and correct electrical hazards. In summary, understanding the difference between ground faults and short circuits is crucial for electrical safety. By knowing the causes, effects, and protective measures associated with each type of fault, you can help prevent electrical hazards and ensure the safe operation of electrical systems. Always follow safe work practices when working with electrical systems, and if you are not comfortable working on your own, hire a qualified electrician. Remember that electricity can be dangerous, and it's important to take precautions to protect yourself and others. In addition to the NEC, there are other standards and regulations that govern electrical installations. These include the National Electrical Safety Code or NESC, which covers electrical safety in utility systems, and the Occupational Safety and Health Administration or OSHA, which sets standards for workplace safety. It's important to be familiar with these standards and regulations to ensure that electrical work is performed safely and in compliance with the law. When working with electrical equipment, always follow the manufacturer's instructions. This will help you to avoid damaging the equipment and ensure that it operates safely. It's also important to use the right tools for the job. Using the wrong tools can damage electrical equipment and create a safety hazard. When installing electrical wiring, be sure to use the correct type of wire for the application. There are different types of wire for different purposes, such as indoor wiring, outdoor wiring, and underground wiring. Using the wrong type of wire can create a fire hazard. When making electrical connections, be sure to use the proper connectors. There are different types of connectors for different types of wire and different applications. Using the wrong connectors can create a loose connection, which can lead to overheating and a fire hazard. When working with electrical panels, be sure to label all of the circuits clearly. This will help you to identify the correct circuit when you need to work on it. It's also important to keep the electrical panel clean and free of debris. Dust and dirt can accumulate in the panel and create a fire hazard. When replacing a circuit breaker or fuse, be sure to use the correct size and type. Using the wrong size or type of circuit breaker or fuse can create a fire hazard. When working with electrical systems, always be aware of the potential for electric shock. Electric shock can be fatal. To avoid electric shock, always de-energize the circuit before working on it and use appropriate personal protective equipment. If you are not sure how to do something safely, ask for help. It's better to be safe than sorry. In summary, understanding the difference between ground faults and short circuits is just one aspect of electrical safety. There are many other things that you need to know to work safely with electrical systems. By following safe work practices, using the right tools and equipment, and being aware of the potential hazards, you can help prevent electrical accidents and ensure the safe operation of electrical systems. And to reiterate the safety recommendations, always turn off the power before you start working on any electrical circuit. Test the circuit to make sure the power is off. Use insulated tools. Wear safety glasses. Don't work in wet conditions. If you're not comfortable working on electrical circuits, call a qualified electrician. When selecting conductors, consider the ampacity, voltage rating, and environmental conditions. Use the correct size and type of conduit for the application. Properly support and secure all wiring and conduit. Make sure all connections are tight and properly insulated. Ground all non-current carrying metal parts of the electrical system. Test all circuits after installation to ensure they are working properly. Keep electrical panels clean and accessible. Label all circuits clearly. Inspect electrical systems regularly for damage or wear. Repair any damage immediately. Replace worn or damaged components. Never overload electrical circuits. Use extension cords sparingly and never as a permanent wiring solution. Use surge protectors to protect electronic equipment from power surges. Install ground fault circuit interrupters or GFCIs in wet locations. Install arc fault circuit interrupters or SIs in bedrooms and other areas where arc faults are more likely to occur. Follow all applicable codes and regulations. Obtain the necessary permits before starting any electrical work. Hire a qualified electrician to perform any electrical work that you are not comfortable doing yourself. Educate yourself about electrical safety. By following these safety tips, you can help to prevent electrical accidents and ensure the safe operation of electrical systems. In addition to these general safety tips, there are also some specific safety precautions that you should take when working with ground faults and short circuits. When working with ground faults, be aware that the current may be flowing through unintended paths. This means that you could get an electric shock even if you are not directly touching a live wire. To avoid electric shock, use a ground fault locator to find the source of the ground fault and then to energize the circuit before working on it. When working with short circuits, be aware that the high current can cause wires to overheat and potentially start a fire. To prevent a fire, de-energize the circuit immediately and then inspect the wiring for damage. If there is any damage, repair it before re-energizing the circuit. Remember, electrical safety is everyone's responsibility. By following safe work practices and being aware of the potential hazards, you can help prevent electrical accidents and ensure the safe operation of electrical systems.